Good evening. From today onwards, we are going to be with revision lectures. That is for DSS for in-semester examination. So now we have first problem. Determine tensile strength of angle 175.6 connected to gusset plate 10 mm. It is connected with 6 bolts of 16 mm diameter bolts. Pitch and edge distance are 40 millimeter. So before going to this problem, we should be very clear about the problems which may asked on this tension member for angle sections. So we have types of problems. So already we have seen in the class, we have two types. One is analysis and second we have design. Today we are going to be with analysis problems only. What is difference between the two? In analysis, we have to determine strength of the section. Strength of given section. What does it mean? So in analysis, section is given. Section is given. And we have to find strength of that section. That is your analysis. What is design? We have given factorial load. And then we have to design the member. So in design, we have to determine cross section also. Determine cross section. Cross section. And after determine cross section, we have to go for analysis. And after analysis, whatever strength of this section, strength of provided section, should be greater than factorial load. And if it satisfies, then my design is okay. Means in design, I have full analysis. So means after determining the cross section, whatever we are going to do, that is your analysis only. So we have these two types of problems. Today we are going to be with analysis and tomorrow we will go with design. So you first write down this part and then now we will switch over to the design of the, analysis of this member. We are going to determine the strength of the section. So now we have given this section. So step 1 we have. So you have to follow same steps in exam. So step 1, given data. What is given? So we have given angle 175.6 millimeter. Now from steel table, you determine its area. We have area of this angle section is 1010 millimeter square. Then again, what is given? Thickness of gusset plate. Thickness of gusset plate 10 millimeter. Pitch is given 40 millimeters. End and edge both are same. End and edge distance. (40 millimeters). Then number of bolts. 6. Diameter of bolt 16 millimeters. So this is step 1. We have all given data. Now we will go to step 2. In this we have tensile strength of the section. Tensile strength of section is minimum of first. So I will write A, yielding of cross section. B, we have a rupture at critical section. Rupture at critical section. And third, we have block shear strength. Third, we have block shear strength. And we have minimum of these three will be our minimum equal to TD, design tensile strength. Now we will start with A part, that is yielding of cross section. Yielding of cross section. Now we have formula TDG is equal to AG into Fy upon gamma m. Now we will substitute the value AG, we have 1010 into 250 divided by 1.1. So calculating this, we are going to get value 229. Check values once. 229.45 into 10 raised to 3 newtons, which is equal to 229.45 kilonewtons. So we have this value, that is first, which is due to yielding of cross section. Now we will go to B part, in which we have tensile strength that is due to rupture. So we have B, a rupture at critical section, or we will write tensile strength due to rupture at critical section. Rupture at critical section. Now this actually we will give number 1. Now we have formula for TDN, that is equal to 0.9 ANC FU upon gamma ml plus beta AGO Fy upon gamma mm. So generally longer leg is connected to the gusset plate because ANC, that is with Fu, so that will gives us larger strength. And AGO, that is with Fy, so always provided smaller area. Fy we have 250 and Fu we have 410. Now we have given, so I will plot the section, connection, and we have given connection like this. So we have given 6 bolts. So I will plot 6 bolt 1, 2, 3, 4, 5, and 6. So we have these 6 bolts and values are given. So this value is given 40. All these values are 40. So 40, 40. So these all will be 40. So I can write it as, so this distance will be 1, 2, 3, 4, 5. That is 5 into 40, which will be 200. And then we have this will be continued. And if we will plot section of this, then we are going to be in this fashion and it is connected likewise. And we have 100 millimeter leg is connected to the gusset plate. So this leg will be 100. So we have 175. So this will be 100. And then we have this will be 75. So now A and C, we have area of connected leg. And that now we know that is, I can write it as depth d minus t by 2 minus diameter of hole multiplied by thickness. And we will substitute the value we have 100 minus thickness we have that is 10 millimeters. So we can see this, sorry, 6 millimeters. So we have 100 minus 6 by 2 minus 16 we have diameter of bolt. So we have this value that is equal to 16 and multiply by 6. So this will gives me value of A and C, and we have this value as 400 minus 3 minus 16 and multiply by 6. So we have this value that is 486 millimeters square. 486 millimeters square. And AGO, so we have this as 175. So we have this distance as B minus T by 2 into T. Now value of B we have 75 minus 6 by 2 into 6. And we will get this value that is equal to, sorry, we have this actually 18 because we have this as diameter of hole and diameter of hole is diameter of bolt plus 2. Till 14 it is 1, after 14 it will be 2 and this value actually comes then. So we have 18 plus 3, 21. So 100 minus 21 into 6. So we have this will be 474 millimeters square. And AGO we will get it as 72 into 6, which will be 432 millimeters square. So now we know ANC, we know FU, gamma ML we know 1.25 and gamma MO we have 1.1 AGO 432, we know FY. Now we have to calculate beta. Now what is formula for beta? Beta we have 1.4 minus 0.076 W by T in bracket Fy upon Fu into Ps upon Ls. Now W we have outstanding leg. So this value we have W. So now I have W at 75 millimeters. T we know 6. Now BS, if you will go to table 6, we have W plus WT minus T. What is WT? WT is this distance. Distance from outstanding leg to the center of bolt. And this WT is generally taken between 0.52 to 0.57 into leg. Keep in mind, this is not from toe. This is not this distance. This is distance from toe, which will be D minus WT. And then we will have this will be 50 to 57. So WT we will get 55 millimeter because leg is 100. So we will get WT 0.52 into 100 will be 52 and 0.57 into 100 will be 57. So we will get round up to 5 if possible, and then we will have 55 millimeters. So I will put values here. So we have W that is 75. So we will put the values BS 75 plus 55 minus 6. And then we will get this value that is equal to 75 plus 55 minus 6, and this comes 124 millimeters. And then we have LC. This is center to center distance between end bolts. Between end bolts. And now we have this distance, this LC. Now this we have seen, this is 200 millimeters. And now we will substitute this value. Therefore, TDN equal to, or we will first calculate beta separately. So we will have equal to 1.4 minus 0.076. W we have 75, T we have 6, FY 250, FU 410, BS 124, LC 200. And then we will get this value that is equal to 0.06 into 75 by 6 multiply by 250 by 410 into 124 divided by 200. And we have into plus 1.4. And we have this value 1.04. And now we will substitute this value and we will get TDN that is equal to 0.9 into ANC we have 474, FU we have 410, gamma ML we have 1.25 plus beta we have 1.04 into AGO we have 432, FY 250 and divided by 1.1. And we will get this value that is equal to, just I will calculate it. It comes 242.03 into 10 raised to 3 Newton equal to 242.03 kilonewtons. This is B part, so we will give it as number 2. And then we have C, which will be tensile strength due to block shear. Tensile strength due to block shear. Block shear. And now you can see this. We require value of AVG. We will calculate AVG. Then we have AVN. Then we have ATG. And then we have ATN. So these four values are most important. Now I will explain how we will go with these values. So AVG, we have to consider, you can see figure 7. So this is given section. So this length into thickness. So we will get AVG value, and that value we will have. Now this total will be 240. So we have this will be 240. So this value we will get it as 240 into 6. So 240 into 6. And we have this will be 1440 mm square. And AVN we have this distance 240 minus, we have how many bolts? 1, 2, 3, 4, 5, but not full bolt because this value is still center. So we have to subtract 5.5 into diameter of hole, which is 18 multiplied by 6. And then from this, we will get 846 millimeters square. Then we have ATG. So we have ATG. Now we have this value perpendicular to this. So perpendicular to this, but towards toe side. So this distance. So now we have WT as 55. So automatically we will get this value that is equal to 45. So we have this value as 45 millimeters. So we will have ATG 45 into 6. And we will get this value that is 270. 80 and we have, so we have 45 minus half diameter hole because it is till center. This distance we have till center. So half bolt hole we have to subtract 0.5 into 18 into 6. And we will get this value that is 45 minus 9 multiplied by 6, 216 millimeters square. And then we will substitute these values in TDB form. So I will go TDB1 and that we have AVG into FY, AVG FY upon root 3 gamma MO plus 0.9 ATN into FU upon gamma ML. And then we have AVG, we have AVG and ATN. AVG 1440 into 250 upon root 3 into 1.1 plus 0.9 into ATN we have 216 into 410 divided by 1.25. And if we calculate this value, we will have this value 1440 into 250 divided by root 3 divided by 1.1 plus in bracket 0.9 into 216 in 410 divided by 1.25. It comes 252.71 into 10 raised to 3 Newton, which is 252.71 kilonewton. And then I will go TDB2 and we have that formula 0.9 AVN into FU upon root 3 gamma ML plus ATGFY upon gamma M. And then we will substitute value in this. So we have 0.9 into AVN we have 846. FU we have 410 divided by root 3 into 1.25 plus ATG we have 270 Fy 250 upon 1.1, and we will get this value that is equal to 0.9 into 846 410 divided by root 3 into 1.25 plus we have 270 into 250 divided by 1.1. It comes 205.55 into 10 raised to 3 Newton, which will be equal to 205.55 kilonewton. So let us, this will be 1, this will be 2. So TDB is minimum of, TDB is minimum of 1 and 2. And then we have TDB equal to 205.55 kilonewton. So this will be, so we have already 1, 2 and 3. So we have value 1, 229.45, 229.45, this is 1. Then we have value 2, 242.03, 242.03. We have 2 and 3, 205. So we have TD, therefore TD equal to 205.55 kilonewton. So we have tensile strength of angle 175.6 is 205.55 kilonewton. So likewise, we have to solve the problem of analysis by welded connection. Next video, we will go with bolted connection. So now we will stop here only. So thank you.